Leo's Tech Talk. Video 46. Wi-Fi interference. Ever wondered why your Wi-Fi suddenly slows down when you need it most? Or why videos buffer even when your signal shows full bars? The answer might not be your internet plan. It could be something called Wi-Fi interference. By the end of this video, you'll understand not just why your Wi-Fi struggles, but also how to reduce interference for a faster, more stable connection. What is Wi-Fi interference? Wi-Fi interference is the disruption or disturbance of wireless signals caused by other devices or overlapping wireless signals. This common issue can significantly degrade network performance, resulting in slower speeds, higher latency, frequent disconnections, and sometimes an inability to connect to the network. Types of Wi-Fi interference. There are three main types of Wi-Fi interference: co-channel interference, CCI, adjacent channel interference, ACI, and non-Wi-Fi interference. What is co-channel interference? Co-channel interference, CCI, is a common wireless networking issue that occurs when multiple devices or access points transmit on the same frequency channel in the same geographical area. Although commonly referred to as interference, CCI is more accurately described as congestion because Wi-Fi devices are designed to share the wireless medium rather than completely block one another's transmissions. How CCI works. When multiple access points operate on the same channel with overlapping coverage, they and their connected clients form a single contention domain. As a result, all devices must share the same frequency for transmission. For example, if access point 1 and access point 2 both operate on channel 40, and their coverage areas overlap, co-channel interference occurs. Consider another example where Belkin and Apple both serve clients on channel 36. Since both APs can detect each other at a strong signal level, they effectively become part of a larger contention domain. All connected devices must therefore compete for airtime before transmitting data. In a CCI environment, a device defers its transmission even when the ongoing transmission originates from a different BSS operating on the same channel. Impact of CCI. Co-channel interference negatively impacts wireless networks because it increases contention among devices sharing the same channel. This problem is especially common in high-density environments such as offices, apartments, stadiums, or public spaces. As stations attempt to access the wireless medium, they may need to wait for other devices to complete their transmissions. During this process, stations update their timers using the network allocation vector value contained in transmitted frames. From the end user's perspective, this can make Wi-Fi appear slow, unstable, or even completely unusable. Mitigating CCI through BSS coloring. In IEEE 802.11ax or Wi-Fi 6, a technique called BSS coloring is used to help reduce co-channel interference. BSS coloring assigns a unique color or numerical identifier to each basic service set in a wireless network. Devices within the same BSS share the same color, allowing them to distinguish between transmissions from their own network and transmissions from neighboring BSS operating on the same channel. This mechanism improves spatial reuse and reduces unnecessary transmission deferrals, resulting in better overall network efficiency and performance. What is adjacent channel interference (ACI)? When wireless signals from one channel spill over into a neighboring channel that is partially overlapping is called adjacent channel interference. This overlapping creates noise and distortion, which affects nearby transmissions. Wireless stations use clear channel assessment (CCA) to check whether the medium is free before transmitting. A weak signal can become corrupted by interference from a nearby overlapping channel. If the interfering signal is strong enough, it may falsely trigger CCA, causing devices to unnecessarily delay transmission. Adjacent channel interference in 2.4 GHz. Most 2.4 GHz channels overlap. Signals from one channel can spill into another, creating noise and reducing network performance. For example, if one access point uses channel 1 and another uses channel 2, their frequencies overlap and interfere with each other. This can lead to retransmissions, lower throughput, increased latency, and unstable connections. In the 2.4 GHz band, only channels 1, 6, and 11 are non-overlapping in the FCC domain. Using these channels helps minimize ACI and improves wireless performance, especially in dense deployments. Adjacent channel interference, ACI, in 5 GHz. Unlike 2.4 GHz, the 5 GHz spectrum provides many more non-overlapping channels, which greatly reduces the chances of ACI. This makes 5 GHz better suited for high-density wireless environments. Proper channel selection and spacing help minimize ACI and maintain better wireless performance in 5 GHz networks. Adjacent channel interference in 6 GHz. The 6 GHz spectrum, introduced with Wi-Fi 6E and Wi-Fi 7, provides a large number of non-overlapping channels. This greatly reduces the likelihood of ACI compared to the 2.4 GHz and 5 GHz bands. Because of the wider available spectrum, More access points can operate without overlapping, channel reuse is improved. High-density deployments perform better. Wider channels such as 80 MHz, 160 MHz, and 320 MHz can be used more efficiently. Non-Wi-Fi interference. Non-Wi-Fi interference is most common in the 2.4 GHz ISM band because many household and consumer devices operate in this frequency range. Bluetooth. Bluetooth devices operate in the 2.4 GHz band using frequency hopping, rapidly switching channels across the spectrum. Because they affect all channels, changing Wi-Fi channels usually does not avoid Bluetooth interference. Bluetooth devices are low-powered and hop quickly, so their impact on Wi-Fi is generally minimal. Interference becomes noticeable only when many Bluetooth devices are active at the same time. Cordless phone. Cordless phones can also interfere with Wi-Fi in the 2.4 GHz band. Some create constant spikes in signal amplitude, while others use frequency hopping across multiple channels. Their operating frequency may change during use, which can often be observed in spectrum analysis tools such as waterfall or amplitude history views. Microwave. Microwave ovens operate near the 2.4 GHz frequency range and can generate significant interference. In spectrum analysis, they typically appear as a broad, mountain-shaped signal. Microwave interference often occurs in short bursts, such as 1-minute intervals during use. The strength of interference depends on the microwave's age, shielding quality, and distance from the wireless device. Let me know your thoughts in the comments if you found this video informative and helpful. In the next video, let's see what is 2040 coexistence and 40 MHz intolerant bit. Thank you for watching.